is Chef Coding, and welcome to second episode of my Erlang tutorial series. Today we will be talking about Booleans, some logical operations, and other data structures like lists and tuples. So without further ado, let's go. Okay, let me introduce you to Booleans, which are available in Erlang. First is obviously I have to go into Erlang shell, and now I can type. First one is true, which represents true value, and second one is false. And actually, if you remember from the last episode, I mentioned you a special data type in Erlang, which are atoms, and true and false are actually atoms, nothing less, nothing more, pure atoms. Okay, let me introduce you now to some of logical expressions. Let's create some variable var1 and let's call it 12, and second one var2 12 but 0.0, so it's still 12 but as float number. Okay, now let's see what's happened when we create that kind of expression. Double equals sign is in Erlang equation equals operator. So now we are we are checking if var1 is equal to var2, which is true because var1 is 12 and var2 is also 12, but var1 is integer and var2 is floating point number. Now let's see second one, equals operator. We are typing it as equals sign, semicolon, and another equals sign, and the difference between both of first equals operator and the second one, both are checking if values are same. But the difference is that the first one I introduce you to does not care about type of these values. That means the first var1 is integer and var2 is float number, but they both represent same value but different types, so they are true because this operator doesn't care about type. But this operator it has to not only have same value but also variables, the values on the left and right has to be the same type. So now when we evaluate this expression, we will get false because var1 is integer, var2 is floating point number. So it can't be true. But if we write something like this, we will get true. Okay, there is obviously bigger or equal operator, and that works totally fine. Less or equal, pay attention to that. The less operator, less sign is on the right side of the equal sign. It's a bit different than in other languages. And there are also less equal, less operator, greater operator, there is also negation. So negation of false is true. It works like not Boolean is the second one, Boolean. And also, fun fact, not is not actually an atom. It's keyword in Erlang language because we can't assign it to variable. Interesting. There is equals operation, and there are also negation of equals operations. So for common equals is negation is we write as slash equals sign and the other value, and yes, 12 not equals to 12, it's false because it is equals. And for the, I don't know, more strict equals, the negation looks like that, equals, slash, and equals sign. So now when we type same arguments, we will get true. And that works fine. Okay, now we can move to pure logical operators like true and true. And this is just implication, and true returns true, true and false returns false. Obviously, we can obviously mix our operators as we like, false and true. That works fine. There is also OR operator. And there are also the lazy versions of and or operators, and I will show you example. And or 2 is not equal to 2. Sorry, that's a normal operator, but the lazy one is or else. So the difference is it works exactly the same. It returns the same value like the normal operator or, but the difference is that, as you know, when we are using or operator, it's alternative. So if the first argument is true, there is we don't care what's the second argument of this logical function, so it also will be true. And because it is called lazy operator, because if first argument is true in or else, then actually Erlang is not going to execute the expression on the right side of this operator, because he already knew the output of this expression. I can show you that for dividing by 0. It's impossible, right? Dividing by 0, but it's actually didn't even evaluate it because or else operator is lazy one. Let's do the same but with the normal operator, and we will get error. And same goes with and. but it is called and also. We will do same thing. Dividing by 0 is a great example, I think, to show you that. Okay, so and also is again the lazy version of AND operator. And in AND function, when the first argument is false, we do not need to look even on the second argument. So we already knew the output of our expression, right? So it evaluate when it's when we are using lazy operator and we see the false on the left side of our function, then it doesn't even look on the right side on the second argument and immediately returns the false value. And that works in the same way. I will show you the normal operator that it will exception error occurred. Interesting thing for sure. The last logical operator, which I forgot obviously, is the XOR operator. So it returns true when the values are different and returns false when they are the same, exactly like normal XOR operator. Sorry, I'm not in. I already exited the Erlang shell, so I have to open it. True, XOR, false, and let's change it to show you the example. And there is the lazy version of this function, because we always have to look on both values to check if they are same or different. And now I think it's already all of the logical functions which are available in Erlang. Let's move to lists data structure. Lists are a new data type which are really new data type, not like Booleans, which are actually two atoms, true and false. So let me show you how to create a valid list. So this square bracket, and now we can type any elements we like. So now I inputted 2 integers, but we can put some floating points number, some string, hello world, let's say. And yes, we can put here atoms also. So and we can close our list and put dot at the end of each expression, and we got valid list. Yes. Now lists, we can say they are always two cases which we have to think about when we are talking about lists. The first case, list can be empty, and this is empty list. And there is no element in here in it. And list can be divided to and described as head, and with pipe, and after pipe we put tail. And this is head of our list. Head is always first element, and tail is the rest of the list, which is also always a list. Let me show you. We can create a list in this way. the first element is head, we will try to create the same list as I created in the first example. So first element is head, but after pipe we have to create a list. So we are opening a new list, and now I try to copy this list. Yes. I'm closing the inner list and closing the full syntax, and we got the same list. We can obviously bound some variable to the list. And that works fine. And now we will come back to this head and tail syntax, because this is first time when pattern matching, which I was talking about in the last episode, really comes handy in our situation. Let's try to create a head and tail syntax of lists, and try to pattern match it to some other to some list just. So let's say it is H. H is like head, goes for head. T goes for tail. And now we are using equals sign. And let's try to put var, our variable, which is bounded to list. Okay, we got return value, which is a right side of our equals. And now let's see what is in our H variable. It's 12, exactly like head in our list. And what is in T variable? It's the rest, it's the tail of our list. Every character, every element of the list after the head is tail. Obviously, when we have some special case, not so special actually, let's create H2 and T2, and because we can't use already H and T, and let's try pattern match it to list with one element. Let's say 13. Okay, 1. And let's see what it is in H2. It's 1 atom. We expected that. But T2 is empty list. Empty list is also a valid list, and it is tail of this list. So tail is always everything in list without first element, which is head. Okay. Now we can create example list, because I want to show you some more examples of pattern matching we can use with lists. So with lists, when we are talking about lists, the order of elements we put in the list is meaningful, right? And now let's try to pattern match some lists. Okay, I am doing pattern matching of the example list, and as you can see, I put a list on the left side of our equals sign, but with only 2 variables and one integer, one value, and this value is in the same place and is on the second place in our list and has value 2. And this is same like in the example list, right? So pattern matching ended successful. And let's see what it is in a variable. 1, like in the place of a in our list which we pattern matched, and b, it should be 3, and yes, that's correct also. There is also a way of concatenating our lists, and we are doing it by putting some lists, let's say some easy one, and placing 2 plus signs, and now we have to input some other list which we want to concat. And yes, that works correctly. We can obviously concat some empty list because it is valid list, and we will get just example list. Also, there is interesting kinda example. Let me show you of deleting elements from lists. Okay, and now we can put 2 minus signs and list, and as you can see, the elements of the lists which we are subtracting are removed from lists on the left of this operator. It is a pretty weird syntax and it's not very often used, but I consider it as fun fact. As you can see, it only deleted the first occurred item. If we would put here a 2 and 3 here, it will delete all first occurred elements of 2 equal to this one, and we will get only 1 at the end. Yes, that's all for now about lists. Now let's move to tuples. Tuples are in some way similar to lists, but much more light-weighted, because we can't manipulate the size and we can't just move out elements of it like we were doing it with lists. We are not describing tuples in the same way like lists. We can't talk about heads or tails when we are talking about tuples. To create tuple, we need to open a curly bracket, and just like in the list, we can put in the tuple whatever you want, whatever values we want. Some string, some atom, and we have to close it with another closing curly bracket, dot at the end, and we got valid tuple. Tuples are fixed length. Actually, lists also are fixed length, but in tuples we can't manipulate. There is no such thing like getting head and tail in tuples. No, it's just not the way we are doing it. Tuples are much more lightweighted. They consume much less memory, and we can pattern match it. Obviously, we can just assign it to some variable. Let's make some easy tuple with 2 elements. Obviously, it's valid expression. There is also some similar pattern matching option when we are talking about tuples. We can pattern match specifying elements But important thing, we always have to know the amount of elements. When we try to pattern match our variable a has 2 elements. To pattern match it, we have to specify tuple with 2 elements on the left side of our equals sign. R1, R2. Okay. These R1 and R2 are valid variables and will be assigned to them the values which are in our tuple. Now when we call R1, we got 2, just like first element in tuple A, and R2 is going to be 9. Yes, that's correct. We can obviously create 1 element tuple, and that looks like that. Will now be bounded to value 13. And the same thing like in lists, we can, to make pattern matching look even better. This is actually very common usage of pattern matching when it comes to tuple. Let's create error. This is atom, obviously. This error thing I've written. Hello world. And let's bound it to variable error message. Okay, and now let's create some pattern matching example. So we are pattern matching tuple, which first element is error and second element is some message. We don't know what it is, but we want to extract it from our tuple. Okay. So now when we call message variable, we will get a message which was bounded to it. Yes, and so far it should be enough. So let's make a quick review. To quit from shell, I'm using q and brackets. This is a function in Erlang which will exit from a shell. We learn about Booleans. There are true and false, and this will return false. There are lazy versions of operators we know, like and, or. Yes, 2 different types of checking if values are equal. The one which doesn't care about type and the one which cares indeed about type. We learn about lists, but this syntax with pipe enables us to extract first element and tail of each list. Okay, head. And H is here head just, and T is a list. Tail is always a list. This syntax won't work on empty list. You have to remember that. Right. It will throw error, exception error, no match of right hand side value, empty list. Because empty list does not have any element, so it doesn't have any head. Okay, also we learn about tuples, which are pretty similar but much more lightweighted versions of lists. Can't be concatenated, can't use this head syntax, but thanks to that they are consuming much less memory. They are widely used. Okay. And we learn about new examples of usage of pattern matching. So we can use a and now a element will be assigned to value 12. Yes, and that's all for now. Thank you for watching and see you soon.